See. Yeah. I put 2 hours, but it will be finished in maybe 1 hour. So don't worry. I put because sometime the issue with the internet and all. I'll take the feedback and based upon that we can publish. Okay, let's start. Okay, so what is 5G private network? First thing, everyone able to see my screen? No, this session is 5G private network, not RAN core. I'll just explain about the RAN and core a little bit so that you can understand. So if you have any doubt, we will discuss after the session in that, okay? So these are the topic and outline that we'll discuss. So first we have to understand what is 5G RAN and what is 5G core and what is 5G. So here we can see, 1 minute, let me hide this page, how to hide this. Here we can see we have 5G category. So basically 5G is designed to support wide range of use cases. So we know that we have 3 different kind of use cases. First one is called extreme mobile broadband, that is called EMBB. And the second one we call URLCC. And the third one we called MMTC. So we have 3 different categories. So EMBB mainly focus on providing faster internet speed and improve the capacity for the 5G smartphone or iPad or laptops. Okay, so this kind of services we provide. So we allow for the things like high definition video streaming and large data download. So our main thing is that this kind of services. The second one that is called URLCC here. Here, mainly they designed to support real-time application, and that required extremely low latency and high reliability. This is the region we call URLCC, ultra reliable low latency communication. So what kind of services it will come over here? So here, such as self-car, industrial automation, and remote surgery. So this kind of services, it will come to here. Third category we can see that is called MMTC. So MMTC is focused on supporting a large number of devices with low data rate requirement. Such as here you can see like sensor, like other Internet of Things devices, like massive Internet of Things devices. So 5G network is totally designed like that. It can support all of these use cases simultaneously. In LTE, it was not happening actually. So this is the reason we have the different portion of the network that being to allocated to each use cases as required. Okay. So here we can see what are the infrastructure required. So you can see here the first one. Here you can see that we have 3 different. So increase data rate in the EMBB, improve the capacity, okay, enhance the user experience, increase the coverage, low latency. So when I'm talking about increased data rate means what? It means 5G network here are designed to provide data rate that are significantly faster than 4G network. Okay, and that allow faster download and uploading speed for the mobile devices. So we have this category. Second one, improve capacity. So improve capacity means what? 5G network can capable of supporting many more devices in a given area compared to the 4G network. So if you are working in the 4G network, the capacity and hardware maximum they can support like 4,000 users in one base station. Here we can support up to 30,000 users in one base station. Plus, we can provide higher speed. Third one, we have enhanced user experience. So with faster internet speed, improved capacity, definitely here EMBB allow for better user experience when using the mobile devices. Okay, so when we are providing this, so definitely we have a smooth streaming of file video gaming, faster download time, larger file. Like 1 GB file, you can download in seconds. Third, also increased coverage. So 5G network are expected here to provide better coverage than 4G network, with improve penetration in the building and other difficult areas. So that's the reason we have multiple solution like a integrated access backhaul. So we can install and we can provide a small cell antenna through that IoT devices. Also low latency. So 5G network are designed to support low latency, means here less delay when we are sending and receiving the data over the network. In LTE still we have the delay and the jitter, so it will create problem. Okay, so when we have less latency, so it will help us to play PS5 game, online gaming, virtual reality, augmented reality. This kind of activity we can get the benefits. And also we can say that 5G help us to reduce the cost per bits. So when I'm talking about reduce the cost per bit, it means introduction of advanced multiple antenna technology like network slicing. 5G network are expected to provide the reduction in the cost per bit of the data that we use to transmit actually. So here is the plus point of the 5G network. Now, when we come to the URLCC, here we can see we have different categories. Like the first category, we have extremely low latency. So what is the meaning of low latency? So when I'm talking about low latency, it means this category URLCC is designed to support latency of less than 1 millisecond. It means which is completely lower than latency of the 4G network. So this is very crucial for the application that required here real time response. So real time response, it means what? Where like self-driving, like industrial automation and remote surgery. So this kind of places is required. Second one, we have high reliability. URLCC designed to support here extremely high reliability. It means what? It means very low probability of packet loss, very low. It means there is no packet loss when they are transmitting the data. So this is the reason why it's important, because some of the applications are very crucial. So when we are transmitting the data, it required accurate and consistent of data transmission. When you are doing the remote surgery, okay, in that time it is very important actually. If any packet loss, it will create the issue. Second, we have increased capacity here. So ERLCC also designed here to support large number of devices in a particular area. It will help us to provide high device density, like you can see like automobile industry, okay, or like you can see that Apple industry, or any industry that has a large number of work scale. Also 5G support here improve the security purpose. So when I'm talking about security, so URLCC network built-in security mechanism to protect against cyber threat, which is very crucial for the application that requires secure data transmission, like a financial sector. Okay, or any idea? Public safety. So this kind of places, we need to be have provide security system, and also they are flexible. Actually, though URLCC is much more flexible. So URLCC network you can design to be flexible and adaptable with ability to support different kind of reliability and latency, and it's totally depend upon your application requirement. So whatever the application requirement we have, that we can do. Okay. The third one, that is more important for the IoT services and private network, that we can say that massive machine type of communication. Okay, so when I'm talking about massive machine type communication, this is very important key aspect for the 5G technology, because here we are focusing on large number of devices with low data rate requirement. So what kind of use cases it will come to the picture? So mostly the use cases here are coming like sensors, Internet of Things. Okay, so this application it will come to the picture. So here you can see that support for the massive number of device. So it means your MMTC network are designed here to support very large number of device with the ability to connect devices such as sensors, smart meter, or industrial IoT devices. So this kind of aspect you can provide. Second, we have low power consumption. So when I'm talking about low power consumption, it means those devices, they design to minimize the power consumption for the connected device. So it is very crucial for the devices that operated on battery power or limited power resources, or not fridge, washing machine, TV, because they are electric power. But the devices, those work on the battery, in that segment, we can do. Second, third thing is that low cost. So MMTC network also very effective. They must design the cost effective. It means because the number of devices are more, so they can design like that. Their cost will be low, so they can able to connect the devices, multiple devices with the low cost. Third one, fourth one, we can say that scalability. So again, your MMTC here, we can say it must be scalable. It means they have ability to support the increased number of device as the number of connected device grown. So your network should be like this actually. Like in 4G we say, no, the 4G technology bandwidth are scalable, spectrum are scalable. The same thing here also, the devices when they increase, they should be like this. Then we have flexibility. So flexibility means what? Again, it can support different kind of devices, different kind of communication pattern in the network. And MMTC is very important. We need to provide better coverage, improve coverage. So MMTC network expected to provide better coverage than 4G network, because in the 4G we have a difficulty to penetrate the building and difficult to reach in some certain areas. So this factor, so this is the reason in the 5G network we use here DFDS OFDM for the uplink. So when we activate DFDS, so we can increase, and this also we added modulation scheme BPSK, because BPSK is 1 bits, so you can transmit your information with the bits in the network. So that's why we focus here. Okay, and security is very important, guys. So whatever the MMT network you build, like a parking sensor or like IoT devices, it must built-in security mechanism so that they can protect against the cyber threat. So which is very critical for the application that requires secure data transmission. Okay, so again, you have to be make sure like this. So this is the introduction about 5G, how the 5G look like, what is the 5G function we have. Okay, so that we call. Now, we can see about architecture of the RAN. So here you can see that this is the 5G RAN architecture. I'm talking generally, okay, because it should be general. So if you wanted to know more about that, you can see our me and I think Mr. Rahim Alijad there video you can find in the YouTube channel. So you can learn more about the RAN architecture over there. Okay, so here RAN architecture, if you see, okay, it is similar to like LT. There is no difference between LT to NR. Okay, so it is almost similar to like LT. Only difference is that instead of MME, we are using AMF. Instead of LCW, we are using UPF. So 5G network, this one I use NG-RAN complete architecture actually. Okay, so in order to support 5G core network, NR need to develop new G node B actually. So when we have to generate, so in a NG-RAN is a collection of base station actually. So either we can say this one G node B, or we can say next generation E node B, and this both are interconnected via XN interface. Okay, they both are connected via XN interface. Both NG-RAN, G node B and next generation E node B are part of NG-RAN, and they can provide the services either 4G network or they can provide the services of LT network. So they have those services to provide anything. Okay. Now, if you see the architecture here, G node B is connected to AMF via N2 interface, and G node B is connected to UPF via N3 interface. Okay, so their function is like this. Here also next generation E node B is connected to AMF, or next generation E node B is connected to the N3, whatever the services. If it is connected to the this one, then it call option 2 standalone, and if it is connected to the next generation E node B, then we call option 5 NG1. Okay, you can launch the LT. Now, so what are the components we required? G node B. So this is the 5G in our base station that communicate with the mobile device and manage the radio resources. So what kind of radio resources they can manage here? So they can manage admission control over the radio interface. They can manage radio interface connection setup or release. They can manage the mobility control in the connected state. They can manage the radio resource management like SRB and the DRB for downlink and uplink for the scheduling purpose. They can manage the quality of service flow management or map to the radio bearer. They can manage between the NR to the LT interworking also, and they can manage with the RAN sharing between the different multiple operator. So these are the functions they do actually. Second one, we have the control plane unit. So your G node B hardware is divided in two parts actually, we can say. One is called CU and one is called DU. CU, we can say this is called centralized unit or control unit. So CU basically manage the upper layer of protocol like RRC or PDCP or STAP. DU manage the lower layer of protocol, RLC, MAC or physical layer. Then we have the data unit or the distributed unit. So this component is responsible for handling the user data and the forward to the core network. Then we have AMF, that is called Access Mobility Management Function. It's a similar like MME, Mobility Management Entity in the LT. So this one has the responsible for managing the mobility of the mobile devices and make sure a smooth handover between the different base stations, and also do the authentication purpose. Then we have the session management function. So we don't have in LT, but here we have in NR to select the user plane function. So they do. Then we have user plane function. It's similar to like SGW. This component is responsible for handling the user plane data and forwarding it to the appropriate destination. Okay, so overall architecture will be like this. So this kind of hardware you need to provide for the private network also. So we will see later. Then we have NR core architecture. So NR core architecture, you can see it's similar to LTE actually, okay, but because we have new interfaces also and new hardware, so we need to provide different kind of services. So in the 5G core network, we need to provide, you can say, new core architecture actually. It means your control plane and user plane must be separated. In LTE, it was not like this. In LTE, your control plane and user plane is together. That's why when we launch non-standalone, so while launching the non-standalone, we need to provide control plane, user plane separation, or we provide here service-based architecture. So only I just want to overview little bit. So that's why I added over that. You can go, I think, in the detail in our website. You can find more detail about in our YouTube channel. There is in more detail what architecture we mentioned. Okay, you can follow there. Okay, now here you can see we have a different architecture. So your device is connected to the AMF, and here we call NAS interface. That is called N1. G-node is connected to AMF, we call N2 interface. Okay, in LT we don't have N1 concept. We call just a NAS interface. Here we call N1 interface. 1 minute. One minute, 1 minute. Okay. So first one, we have AMF. So what is AMF? AMF is like access mobility management function. Okay. So AMF basically responsible for managing your mobility of the mobile device and make sure a smooth transition between different base stations. AMF also managing your deregistration and registration part. AMF also managing your authentication. AMF is directly connected to the UDM here. You can say that Unified Data Management. It's a like HSS in LT. Okay. Uh, to get the subscriber information and do the authentication. So UDM is connected here, UDR, Unified Data Repository System. Okay. These are the basic functions. Now we have SMF, Session Management Function. This session management function responsible for managing the session between mobile device and the core network. It means we need to manage the setup, modification, and the termination of the session, as well as managing the security aspect of the session, as well as to select the user plane function with the help of N4 interface. Then we have UPF. So you can see that G-node is connected to UPF via N3 interface. And in LT also, we use the same GPRS tunneling protocol. Here we also use the same GPRS tunneling protocol. So G-node is connected to UPF via N3 interface. And here UPF is responsible for handling user plane data and forward this data to the data network. UPF also perform your data plane function like packet forwarding, quality of service enforcement, and provide the security to the system. Other are new. This are new. This also new. ESF, you can say that in LT it was together actually, HSS. ESF authentication server function actually. Okay, that we use for the authentication purpose. Then we have the PCF. So in LT, we call this one is PCRF. Okay, PCRF means policy control function, and this manage the network policies like quality of service. In LT, we do the same function. Okay, they also manage the allocation of resources like a bandwidth to the subscriber. Okay, this one. Then this one is the new one. That one we call network slice selection function. This network slice selection function is responsible for selecting the appropriate network slice for the mobile device and make sure the device connect to the correct slice based upon the service requirement. So I uploaded in YouTube channel about this in detail for 2-hour video you can find in CafeTele YouTube channel. I think Mr. Rahim also uploaded about network slicing in his YouTube channel. So you can also find, visit both the YouTube channel, you can find the stuffs over there. So this is the basic architecture, guys, about core network. Okay, I just want to overview because I wanted to explain what is the hardware architecture. So what are the things is required? We will see next slide. Okay, let me see the chat message. You can find CafeTele Telecom training, or you can find Mr. Rahim Nawai. Okay. No, Carlo, the MMTC device price estimate to depend upon the device to device. Okay, like if you purchase the Samsung MMTC fridge, that is very expensive, $5,000. Okay, so but so it's depend upon that. When you do consider a provide enterprise, a CSP will support URLs, assuming they have the 5G 2x network. Yes, it will support. Okay. Somebody asked the question here, how to implement network slicing. So Ganesh, in YouTube channel, I mentioned one 2-hour video about network slicing. You can find. Okay, guys, so enter to the 5G private network. Somebody guys joined recently, so welcome back, everyone. If you have any doubt, any questions, so you can ask to the chat message. Okay. So what is private network? The first thing is coming to the mind actually. So when I'm talking about the private network, so 5G private network, we had in LTE also private network. So 5G private network, we can say that it's a private network, cellular network that utilize the 5G technology. Let's see the next slide. Here you can see that in the private network, you have three different scenarios. One is called base station, one is called core network, 5G core, and one is the company enterprises network that we can see what are the required. So any 5G private network they need to provide high speed wireless connectivity for a specific group of users. It's not like that you can provide for like all the users. So what is a specific group of user? Like Apple said, okay, I am looking for the 5G private network. So they need to provide these services and to the Apple. So only Apple users can use those services. So 5G private network use the application industry 4.01. Okay, this one they can use. So like in industry 4.01, we can say smart factories, critical communication, massive IoT, industrial IoT. 5G private network can be deployed in a variety of way, including on-premises, or we can deploy based upon cloud-based or hybrid-based. Okay, so when I'm talking about on-premises deployment, it means we need to install 5G infrastructure inside their premises actually. So when I'm installing, so I need to provide them 5G base station, 5G core network, and a router, switches, and other enterprises services that we'll see. So they can directly, we have to install like in their premises. That is called Apple office or any office, IoT industrial office like a automobiles factory. So they need to provide. So why we need 5G private network? So 5G private network provide high speed connectivity. Why? Because in the 5G network, we have the advanced technology like millimeter wave spectrum, like massive MIMO and beamforming. So millimeter wave is unlicensed spectrum. So 5G in our private network make use of higher frequency band like a millimeter wave, which have wider bandwidth than the current one that we are using right now in the LTE. So when we have this much, so we can provide more devices and that can connect to the network at once and data transmit more faster than LTE. Then we have the concept like beamforming concept. So beamforming here uh, provide direct radio signal toward the specific devices rather than broadcasting all the directional. Okay, so this will improve the signal quality and this will improve the capacity by reducing the interference. So that's why beamforming is important for the higher spectrum devices. Then we have massive MIMO. So massive MIMO means what? Multiple input, multiple MIMO. Okay, so 5G in our here also they provide multiple antennas, so it will increase the capacity. Okay, so in this diagram, if you see, this is the enterprises campus like operator, logistic, manufacturing, distribution. This kind of users need 5G private network, not in your house. Like if you are the owner of one house, if you are asking the operator, okay, I want 5G private network, it will cost you too much. It's definitely very expensive. Okay, you need to install 5G base station in your house. 5G until unless you are very rich. If you are rich, you can make your private network. So you need 5G private local computer like this, multi-edge computing if you need, core network. Okay, so this kind of services you need, and network slicing. So with this, this is the simplified architecture we can say that we have, okay, that we provide. So in simple term, if you confused about 5G private network, don't get confused. 5G private network is just base station that you are using, or a Samsung, Ericsson, Nokia, Huawei, Alcatel, Altiostar, Veneer, whatever they are providing, Cisco, their core network, company network, enterprise service that we'll see later. Clouds, you need cloud also, so you can use any cloud, any hardware system. Okay, now we will see what is the benefit of the 5G private network. So what are the benefits of the 5G private network? So benefit is that we have the technology enhancement advancement. First thing is that we need to do technology advancement. So in the technology advancement, 5G has 3 different categories that we can use. Network slicing, multi-edge computing, network automation, virtualization, and the cloud native that we can do. Second is that new spectrum. So rise of the shared spectrum and the dedicated spectrum for the enterprises that we have. Third one, we have demand on digital transmission. So limitation of the legacy network like Wi-Fi 6, wireline. So we need to provide higher demand. So with the help of 5G private network, we can provide the services. So here you can see benefit of the 5G private network. So we can see here, we have the improved performance. So when I'm talking about improved performance, it means we can provide better throughput, better scenario. Okay, we can provide high speed connectivity. So whenever we can provide high speed connectivity with low latency for the industrial like automation, robotics, and the remote control, private network is very good. Then we can increase the capacity also. It means with the help of 5G private network, we can support more device as compared to the 4G network. And this is suitable for the factory, industry, stadiums. Then we can provide flexibility. So here we can see flexibility. We can provide the network in a way like premises. We can install the hardware. We can provide you the cloud-based private network. We can provide you the hybrid private network like this. Second one missed, that is called security. So 5G private network provide very enhanced security features. Okay, with the help of network slicing and the other concept, we can create the virtual network within the same physical infrastructure. And this can be used to create separate and we can secure those network with the different group of application. Then we have the local control. So we can control the services by ourselves, no need to control by somebody else. Then we have the dedicated coverage. So 5G private network provide improved coverage and the capacity in hard to reach the area. Like sometime if you see, if purchase the AT&T mobile or Airtel mobiles, okay, and you are not able to get the coverage in the industry. So with the help of 5G private network, you can provide these services much more better. Okay. So overall, we have a gain. Now we have the cost saving. So definitely it's cost effective because any 5G private network can be more cost effective than the traditional wired network for different kind of use cases. Okay, like in the remote area, normal wireless network will be costly. So with the help of private network, we can get better services. So overall, we have beneficial for the private network. So if we compare with the 4G, 5G private network with Wi-Fi 6, you can find you have in Wi-Fi, here you can see Wi-Fi 6, you will just have indoor area capacity or little bit factory, don't. But in the 5G private network, we have the optimization for outdoor coverage plus outdoor plus indoor both. But in Wi-Fi 6, we have only inside the indoor. So the target application in the 5G private network, we can keep for the outdoor worker, we can keep for the outdoor assets, augmented and the virtual reality apps, massive industrial IoT application, and the factory. So a end-to-end enterprises manage secure connectivity we are providing with the help of 5G private. I'm not providing, the network operator, they will provide you. Okay, so here you can see that private 5G, 4G compared with the Wi-Fi 6. So when I'm talking about, we already discussed a lot about 5G. So here benefit is that higher reliability and lower latency. Now you know we have built-in security system. We have seamlessly transition connection between indoor and the outdoor coverage available to the self-control through the network by enterprises. So these are the key benefits. In Wi-Fi 6, what is the benefit? Definitely you have high speed, no doubt. Low cost for the Wi-Fi 6E modem, wide ecosystem. Yes, Wi-Fi 6 will support the massive MIMO also. Easy to installation and deployment. This one is little bit tough to install and deployment because there is a set of procedure that they have to follow. Unlicensed spectrum available for all the Wi-Fi devices. Yes. What is the good option for network requirement? High reliability. New revenue generating services they can provide. Good and high bandwidth network and excellent indoor option for the use cases. But drawback, we already see what are the drawback. They only support inside this. Rest of the cases, they have the lagging. So this is the reason 5G private network will support more, and it's more useful than you can say that Wi-Fi 6. Okay, guys, so let's take a break for 5 minutes. I'll have some water, then we will continue. Okay, I'm back. Okay, we will start in 1 minute. Okay, guys. Now we will see the deployment scenario actually, how it's look like. So here you can see that in our private network deployment, so how we can do for the different kind of services also. So when you have no coverage, so you can deploy the 5G private network new radio for the reason is that outdoor and the remote location, and we can have the different kind of application and the server like mining, energy, transportation, utility, existing 4G deployment. Okay, that we can do. Special devices that we can do. Then public LTE to directly 5G private network, so lower cost and the better coverage that we can do. The region, the location, again the same that we can follow. Wi-Fi, if you are using the Wi-Fi services, based upon that, we can change to the Wi-Fi to the 5G private network also, like indoor, outdoor, deterministic coverage, clean spectrum, security reliable, like industrial indoor and the outdoor, the venue and the apps and the devices we can use. Ethernet to the PNR we can also do. VHF, HF2 also PNR we can do. So we have options like scenario to deploy based upon the different solution actually. Okay, so I think in the 5G we can see more 5G private network as compared to the LTE. The cost definitely it will lower as compared to the LTE also, so we can provide. And the PNR can be used CBRS, other shared spectrum or the licensed spectrum. So it's totally depend upon the services they can use the spectrum also. We will discuss about that spectrum in detail. So in our 5G private network, we have a different deployment scenario. So in the 5G network, the private network can be create, you can say that non-public radio access network also. Okay, so here NR deployment can be done in the different way. So the first one you can use a dedicated spectrum. So private network can be used dedicated spectrum that is allocated for the actual radio framework that is only dedicated for the private network. So this can provide increased capacity and perform better for the private network. It can create the NR overlay. So NR overlay is created by adding the private 5G network on top of the existing 4G network that you have right now. Then deploying NR in the unlicensed band or unlicensed spectrum. So NR can also deployed in unlicensed spectrum, which is not allocated to the specific use and can be used by anyone. So they can also create a 5G private network with the cost effective, because spectrum definitely is expensive. So if you have the spectrum in that way, it could be the less cost. So here you can see we have different kind of solutions. So we will discuss first LT solution, then non-standalone solution, and then a standalone solution, how we can do actually. So this is a Cisco private solution actually, 5G LTE private solution, how they deploy in their network. Okay. So here, if you see in the LTE, uh, if I want, if like if you are operator, okay, and you are saying I'm looking for the 5G private network. So any industrial company or industrial factory or anything, they are looking for the private network. They ask operator, okay, like Airtel in India, we have, I am looking for the 5G private network. So whether you have the solution or not. So any private network, first you need to identify what kind of hardware requirement you need. So the first thing is that hardware requirement here is that inode B. Okay. This is the primary transmitter and the receiver of the LTE network, because here your 4G base station connect to the mobile device and the core network. Here it will connect. So you can deploy in a different way. Like here, you can use the inode B to deploy in the macro shell. Okay. Also, you can deploy a small cell. Also, you can deploy some kind of other different capability. So macro shell you can deploy for the coverage, and the small cell you can deploy to provide the capacity in some specific area there you cannot reach by macro shell. Second thing is that you need EPC core network, that is called evolve packet core network. So the core network of LTE that include mobility management entity and serving gateway user plane, serving gateway control plane. Okay. So here you need MME, LZW, PGW, so that your evolve packet core is responsible for routing the data between the base station and internet. This is important. Then what is the function for the MME here? If you see, inode B is connected to MME via S1 interface. So MME responsible for managing the controlling of LTE network. Also, MME here provide you authentication, authorization of the mobile device that can set up between the 4G private network to device to the network. Then, apart from this, we need the most important, that is called security gateway. Okay, security gateway is important to provide the communication and data privacy, because your data must be encrypted and your data must be secured between the mobile devices and the network, and you need firewall. So apart from that, this is the general hardware that we know that that is required. Apart from that, to provide the 5G private network, you need enterprises LAN, you need orchestration. Okay. So here we have different kind of services. So this enterprises LAN that is connected to the inode B, and you can say that it is connected to the LZW. Their function is that because this is software based, so this is used to manage the LAN within the enterprises actually, and it can use to configure and manage the switches, router, and other network devices to make the LAN up always. Okay. Then we have different platforms. So if you have idea about this platform, basically this is server actually, that we can say that. So this is Cisco based. For the Intel, for the Dell, for the different vendor, they have the different kind of services. So if you see the platform like X860 server, it's a server actually. So you need a different kind of server like X860 server, and this server you need to use as a processor that can run a wide range of operating system. So this kind of server we use in the private LT network to support to deploy the virtual network function, okay, to inode B and serving gateway. So you need this kind of platform actually to deploy. Then you have UCS server. So this is the server that we use to optimize for the virtualization and the cloud computing. So they can use here for the LT network to support to deploy the VNF. Okay. Then you can see that we have ISR4K. ISR4K is a server that we use for the different services also. So here we have like a router, because this one we call router. So in Cisco system they are using this one, and this router you can provide the routing security and access network connectivity feature. For the different vendor, you can use for the different router actually. Then you can see here we have ENCS, that is called Enterprises Network Compute System. Okay, this platform of the network, that is called network function virtualization, or this is a combination of NFV plus SDN. Okay, that you can use. So this help us to deploy and managing the virtual network function better. Then we have the CSP, that is called communication server provider. So every company need this kind of service so that they can provide the telecommunication service like voice service, data service, video service, VoIP services. So depend upon the customer to customer, they can deploy. Okay, then you can purchase public cloud. See, everything is connected here, platform, then they are connected. You will understand. I will explain you this one. Then we have public cloud network. So public cloud network you need. Why you need public cloud network? Because when you have the public cloud network that you are using, so they provide the services like AWS, Azure, Microsoft, or Google Cloud Platform. So they can use to deploy your virtual network function and other function to support the private LTE network. So you need, if you want to deploy the VNF and SDN in the cloud base, so you need cloud services also. So this platform provide the flexible and scalable solution for the private LTE network and allow organization to deploy the manage their network in a better way. So overall concept is this. Now here you can see that this SGW is connected to this. Okay. So what is this? So inside this, if you see, that is called NSO. NSO has the access management and they connected to this part. Okay. NSO means what? Network service orchestration. It's a these all are software based actually, this hardware here. So NSO is basically software based. We used to manage and automate the deployment, configuration, and the network configuration, so that we can configure and manage the base station and EPC easily. Okay. Second one we have here private LT or 5G orchestration. So this one we used to manage the entire LT network. So it can be automated and manage the deployment configuration. Again, here we can do to access the resources. Then we have here control plane tenancy orchestration. So we need this control plane tenancy orchestration, okay, because we need to configure and manage the mobility management entity, serving gateway entity, PGW of the network, because they work on the control plane. So that's why we have the connectivity from here, you can see, okay. Now we have UDC, that is called user data consolidation. So this is again the cloud-based software based that we use to manage and store the data for the subscriber of that network, the private network. So that you can do. So overall architecture for the private network, you need this kind of hardware. If you have the hardware, then you can provide the services. So this is very important. In totally terms, we can say that integration. Okay. So when I'm talking about integration in any private network, it means it used to connect the cellular network, LT, or network system within the organization. So this integration point allow for exchange the data and communicate between the private LT network and other system so that we can do the connectivity. Okay, so that is very important. So here, I hope it is clear, guys. Any doubt you can ask me. I will give you the answer. Then no issue. Same thing. It's come to the non-standalone. Now the hardware requirements change actually. So when it comes to the non-standalone and you wanted to launch the 5G private network, so you need one G node B, you need one E node B. The rest is same. Okay, the rest is same, but okay, that. So access management handle the G node B and E node B part. Enterprises management handle this part. Control plane latency will handle the MME and SGW part. And UTC, where you store the subscriber data, that will manage by HSS and CCRF. So you need this kind of hardware. Okay, so 5G NR based station is mandatory because your primary transmitter now is G node B. So G node B is your transmitter and the receiver. So here, your in G node B connect your mobile device or any laptop or the any WLAN device that will come connect. 5G core network we don't have here, but we have EPC core network because it's a 4G network with the non-standalone. If it is non-standalone with options 7x and 4x, then you need 5G core network. But if it is with 3x, then you need EPC core network. You need to provide firewall. You need to provide air network management system to access the network. So overall, this kind of configuration you need to provide. Now, the first one we have NSO. So NSO, we know what is that. I already explained you. The second one we have access management. So access management is a software-based device that access the 5G private network, and they are connected to G node B and the E node B both, so that they can authenticate and authorize the devices and access the control plane. UDC enterprises network, we have enterprises network. You can say that it's a kind of network that can manage the your complete enterprises services. Okay, here again we have the same services you need. So this one already I explained you. See, the architecture concept is same. Only the when the system will change from standalone to the non-standalone or LT to the non-standalone, the system architecture will change. The rest we are using the same kind of concept. So when I'm talking about 5G non-standalone private network that can work together with the current existing LTE network. So in non-standalone mode, the 5G NR carrier is dependent upon LTE. It means the user plane will handle by G node B, but control plane is handled by E node B. It's mandatory because LTE is your anchor and 5G is your secondary node. So it is very important when we want to create a 5G private network with the non-standalone, we have to make sure that the control plane handled by 4G network. So when the control plane handled by the 4G network, so the 5G NR network must be separated the control plane for the public 5G NR network. So you have to design your hardware like this so that you will not face the issue. So this is the 5G non-standalone solution. And the last one we have that is called a standalone solution. So when I'm talking about standalone solution, we need G node B for mandatory. You need G node B1, G node B because you have to deploy. So in the customer premises, you need to install one G node B. It's totally depend. They want macro site or small cell. Okay. Then we have to provide UPF. We have to provide for AMF, SMF. It means we need to provide 5GC core network. Okay. Here you need to provide additional things also because here we have the capacity for the massive MIMO beam forming. So these kind of services we need to provide. Apart from that, we need to connect G node B UPF Ethernet LAN. So Ethernet LAN, this will manage the switches and the router inside your network devices. Then we have different kind of platforms that is called X860, UCS, ISR, 4K, ENC. So it's totally different. If you are using Cisco, you have to use this one. If you are using Huawei, Nokia, Ericsson system, so you have to use their system. But yes, you need all this kind of configuration, different version actually. So this platform, we need to provide the necessary so that we can compute and store the resources for the 5G standalone network. So EPF exit the server that we have and the UCS platform we have that we need actually. So what are the function actually? So if you see this X60, it's like a server, okay? So this is basically we use to manage the you can say that trafficking also to manage the data, okay? UCS is again the server, it manage the capability, okay, it manage the expansion of the network, okay, use for this. Then this again we have a router, so we can use different router also because you need router for designing the enterprises services. So you need to get this router or any other router can purchase, no issue. Then ENCS, enterprises network computing system. So this is very important for NFV and SDN that we need to provide. Then we have CSP, communication service provider. So you can use for the Dell or you can use for the Intel, any, or you can use for the operator vendor like Huawei, Nokia, anyone you can use. So it provides the telecommunication services. Then we have the public cloud, so that you can use for the anyone actually. So public cloud you can use for who, AWS, or you can use for that like is Cisco, whatever the public cloud is coming, anyone you can use, no issue. Okay. So overall, we need to provide a complete package. So the vendor or operator who is providing the 5G private network, they need to provide complete package to the subscriber who is going to purchase the 5G private network. Okay, that is very important. So this is the complete architecture for three different scenario. Now in the 3GPP also we have the concept. So release 16, okay, in the release 16 you can find about 5G private network. 23.501, there they mention about 5G private network actually. So we need to go over there and you can search. Okay, so here we have two type of scenario. One is called standalone non-public network, and second one is called public network integrated non-public network. Okay, so in the release 16, they address unique network identification and the access control for the private network. Okay, so in 23.501, you can find these two. It's still, they didn't mention much more, but we can see. So a standalone non-public network is a scenario where the entire network RAN and core is deployed on the site, like inside the factory. Okay, so a standalone public network that is not connected to the public network, you can say that. It means normal people cannot access that network. Okay, that we use for internal or private communication. So that's why we say private network. But in 3GPP, you cannot find. You have to naming like this. So SNPN, we use in organization, they want to protect the internal resources and data from the external threat. So they use complete separate different type of traffic for the different purpose. Okay, because they want to make sure we have to secure the remote access for the employee and the partner. Okay, so when we wanted to create the SNPN, we need the services. In these services, you need different kind of services like a router, like switches. So that we have seen just now, or the most of the things, firewalls, VPN, a load balancer, network segmentation, okay, cloud, NMS. So you need this kind of services here also for each thing. So router we need to connect the different network and to route the traffic between them. Switches we need to connect the different devices and network to manage the network traffic. Firewall need to protect it from outside. And okay, so we need to provide different kind of services here. That is mandatory. So SNP, that is also called a standalone or non-public network. But still they are working because still they have some issue in that. Okay, so we can see in the future about this. So how they manage SNP services connected to the 5G core network, NG-RAN, G-Node they have to install, and they have in that they have different kind of NID support system model. So they manage this locally or they manage universally. So universally managed by the regulatory, like operators. Locally they can manage also. That SIM card they can use actually for the purpose. So overall, now we can see about industrial IoT and the 5G. So here you can see what is that. So if you are aware about that industrial IoT, uh, what are the hardware? So industrial IoT, basically we can say it's referred to use the IoT devices for industrial purpose like manufacturing plant, energy facility, and the transportation system. So this system are typically used to provide improve efficiency, reduce downtime, and increase the productivity. The second one that we call 5G IoT or massive IoT, where the IoT devices need large scale of devices like smart cities, connected car, agriculture segment in that purpose. So the main focus of the massive IoT is to gather the large amount of data that we can use to improve the overall function of a specific industry society actually. So this is the purpose that we used. Okay. So when I'm talking about three different category, you can identify where we have what kind of services. So here we can see the industrial mode, and here we can see the massive IoT mode. So industrial IoT we used. Okay. So here we can see the services, how it's look like. These are the industrial verticals that we can use. Wirelessly integrated security system, wireless enable automatic production line, wireless enable automatic warehousing, wireless enable automatic logistic loading, local multi-edge cloud improved responsiveness, local IoT. So this kind of service we will use, guys. Okay, now we can see right now we are here. I think by 2025, you can see the business of the IoT growth forecast. This is not you can see, but forecast. So it will go to this much level actually. So definitely it will go because the devices are coming more in the market and the services it will come. So private network for the IoT, 5G drive for the IoT, you can see hyper connectivity, high bandwidth capability, large number of devices, edge pervasive compute, RTLS processing one, and computer slicing. So these kind of hardware you can see, all it will come, IoT devices, and they will connect to the 5G network. So private network for the IoT, how it's look like. So IoT 5G will have significant impact on X vertical device connectivity. X. So industrial IoT, URLCC, and TSN like service support, industrial automation and the control. Enterprises, fixed wireless and collaboration, transportation, connected transportation, maintenance, entertainment, healthcare, massive data set, and the real time energy, this one. So you can see in future, each and everything is going to connect to the 5G, and we can have a multiple vertical option also. Right now, we just use internet, nothing else. We don't use 5G efficiently to use for the different segment. But in future, the market will grow and the 5G market will impact the overall revenue of the country and the operator also. So here, guys, you can go and you can also see the organization they do for the IoT devices. So these are the verticals they have: service requirement, architecture requirement, enablers, and connectivity. In this vertical, you can find smart city, connected transportation, smart home, public safety, healthcare, utility, industrial, and enterprises. So you can find they are working for this organization. When you find for the service requirement, you can find low latency, low cost, critical high priority, high throughput, massive scale, multi-tenant. This vertical, they are working for that. You can go to their website and you can find more detail about that. Architectural requirement, uh, scalable, flexible, interoperable, quality of service, secure, 3GPP and NGNM, they are working. Enablers, they are working. Connectivity, they are working. So you can find connectivity means E node B, G node B, these things. Enabler means like services, SDN, VDN, Open RAN. Architecture, this one. Service requirement, they will. So they will design. So you can find more specs over there and you can identify the solution. Okay, now we can see the 5G private network for the spectrum. So spectrum option for the private network, and it's all about the spectrum actually. You can see that mobile system, fixed link, TV broadcasting, satellite system, weather radar, military radar. So you can see all about the spectrum, audio, radio. It means we are covered with spectrum, everywhere is spectrum. Railway, train, communication system, maritime, interterrestrial space, everything is spectrum. Okay, in everything is work on the frequency actually, we can say. So they all work on frequency, and so a spectrum is a wireless service provider most valuable asset. It means this is the most valuable asset than anything else. So each and every operator need a spectrum. So we need that a mix of a spectrum is needed for success in the 5G. So we have low band, that is for the coverage, mid band, little bit coverage, but capacity, high band, the capacity. You can see we have the coverage chart, we have the capacity charge. So when we have the blue line, that we can use in the urban, suburban, rural coverage. This one, urban, suburban, this one. So here the bandwidth will be low, but coverage will be high. Here bandwidth will be medium. Coverage also better than this. Sorry, coverage low. Not low, mid low. Here, very low coverage. And bandwidth is very high. So we will get higher throughput here, lower coverage. Medium throughput, medium coverage. Low throughput, high coverage. So low band below 1 gigahertz, mid band 1 gigahertz to 6 gigahertz, high band above 24 gigahertz. So here you can see we have different kind of spectrum, low, mid, and high band. So coverage high, capacity low, mid band medium, this one. So you can relate. So you can identify 5G NR, sub gigahertz. So these are the applications that you can use actually. So this many applications we have. So private LTE network completely separate. They have V2X, LTE IoT, VoLTE services for the voice, existing LTE deployment. So we have different kind of services. So the first one, we have licenses spectrum, that is strictly regulated approach. It means operator need to purchase from the government. Here is no rule. Second one is that unlicensed spectrum. So all device can access this spectrum. No control of number of devices in this specific space, but interference will be high. Okay, so typically Wi-Fi network operate. So currently, US allocation unlicensed spectrum are more than 500 megahertz in low band. Shared access, a regulatory framework that allow for the several users in same band. Okay, that allow operator in the same band. And that is called CBRS, Citizens Broadband Radio Service. Then locally licensed dedicated. So spectrum set aside for the particular use and the license, the spectrum available for the non-SP deployment actually. So depend upon we have ability. So we have the CBRS structure and operating rule. So there is a website. In that website, you can identify this rule actually. Each country have their own rule. You can see in FCC license actually. So there is a spectrum range between 3550 to 3700 megahertz. A spectrum is shared. Okay, tiered access model. Incumbent with the highest priority access, the lower tier. So they have the spectrum access system actually. So this one, they can use for the different services actually. So depend upon the priority they can access. So you can see in this, there is one website, I forget the name, FCC license, you can just search in Google, CBRS, FCC license. You can find the whole detail about this and the license. So a spectrum for the enterprises, we can see here, for the local LTE and 5G network. In North America, like US, they assign 2.5 gigahertz for the 5G macro, 3.7 to 4.5 for the SP 5G. Shared, they assign CBRS this much. Locally, don't know. Europe, SP managed play, service provider, SP means license shared access 3.8 to 4.2 shared. Germany, this one they provided. Asia, service provider managed play, it means they can find and they can play. Mid-band, service provider 5G mostly outdoor. Japan 28.2 gigahertz. So 5G goal include both. So guys, they can assign and they can use also. Sometimes they can use. So you can find more detail about this. Okay, guys, thank you so much. Now we will see the questions. If you have any, I hope you like the webinar. If you have any doubt, so please let me know. Now I can see the questions. Let me connect my another. How was the webinar? Please feedback. If you need any improvement, let me know. If you want to add anything, please let me know. I'll see the Q&A and we can discuss now. You can follow me here. So let me see the question actually, then we will discuss. Okay. So I have joined late. Okay. We will get, yeah. I sent same question on chat. Sorry about that. Can ask. Okay. We can give the mic access also. If you have a doubt, we can ask. How I can give the mic access to all. We can speak also, guys. I give the mic access to some of the people.
Hi, so first one here. Thank you so much. It was a great seminar. So the question that I had on the Q&A is, what could be the impact of shared access spectrum on mission critical applications? I was talking to other experts about the implications on reliability, because mission critical applications sometimes are supposed to run without failure for a long time. And I think that's not possible in shared spectrum. Or I wanted to understand also if there's any research in that direction to make it more reliable.
Yeah,
Thank you.
shared spectrum is definitely a problem actually. If you, so you need to identify, okay, see, if you see African countries, they use shared spectrum more actually, as compared to any other countries, region I know. So when we are using the shared spectrum in the private network, okay, you mean one operator, it means the same industry are using or what? Can you explain me again? Pardon?
It's more like a broad question because actually I'm founding a company. I want to work on the private 5G network area, but I'm still collecting some information about this market. Actually, I wanted to be able to provide access to factories, provide private 5G access to factories or hospitals. It was my main idea. So I wanted to understand
Okay, okay, I
how
understood,
feasible
understood.
it is.
Okay, it means like in two, or you can say that one factory is here and beside there is another factory. So when they are using the shared spectrum, so there is definitely the side effect. The first side effect is that interference. But in the 5G, we are using the OFDM technology, so maybe somehow we can somehow it will be okay. Okay, but when we are using the interference, the problem of interference is that when multiple party are using the same frequency at the same time, so interference will increase more. And in 5G, we are using TDD network. So when I can explain you, when we are using TDD network, okay, it create more interference actually as compared to the LTE. But in the 5G, our PCI is designed like that. In the 5G network, somehow it can do better than LTE. Second thing is that the limited capacity. So if the frequency band like PRB utilization is completely 100%, in that scenario also it will create the problem. It means the limited capacity for the user speed will be low. Third thing is that you have the problem for the coordination between your server to another one that they are using. It means so that's why you have to somehow make the border between them, so it will reduce the interference.
Okay, thanks. Just to clarify, so is this the case, for instance, for CBRS in the US and LSA in Europe as well? When I was asking about shared spectrum access, I was actually asking about this.
No, for every country have the different. You can see the in search in the Google CBRA FCC rule and regulation. So there is a rule and
Mhm.
regulation complete big detail they have to follow when they are deploying the private network.
Mhm. Sure. Yeah, I
Okay,
just wanted to understand because I see that that problem
because
could be
because
possible in.
CBRS because CBRS is basically the shared spectrum. So when the they have the shared spectrum and they have the criteria of the frequency band for the license and unlicensed. So here they have to get how many subscriber you wanted to connect in that spectrum. So if your user already using the CBRS, okay, for private network, so your priority will be more than the new one actually it come. Then you need to get one private priority access license. Okay, so it means the user who has been granted license, they will use that spectrum for this specific period of the time. So this kind of services they have to provide.
Oh, okay. Thank you so much.
Yes, yes, thank you. Anybody else? Let me see.
Hello, Abjit. Good evening.
Good evening,
Can
Bhupender.
can you hear me? Yeah. So I was just asking about the requirement of deploying a kind of a prototype to a private network. So I'm not talking about the big enterprise or something, but right. Suppose if I want to deploy it for just making POC, proof of concept kind of thing. So
Hmm?
what are the requirements actually for that? Actually, a big machine,
No, in that
a big or
in that case, you can
yeah.
go for the cloud. I explained you. You can go for the
Okay.
cloud based. You don't need to deploy big machines.
Okay. So,
Yes.
and what about the open source software that are actually being somewhere? Uh, Actually, we need to actually pull them, or where to go actually to get this open stack for this access network and core network for 5G private network?
You wanted to do the open private network. You don't want it to create with the like operator and third party there providing the services.
No, just kind of no, not that one, like the private network stuff. Like it's not like a very open public network. So I have heard like that the stacks are available somewhere. You have to pull them in Docker and just actually
I have to check
make
that. I
it.
don't know. Maybe in the next webinar, I will put your questions, and next webinar I will put.
Okay, yeah.
Okay.
Thank you.
The top, who asked this question? Top companies work for the private network. So Cisco is there, Samsung is there, Dell is there, Nokia is there, Huawei is there. These are the companies, the top companies, they are working for the private network. Okay, apart from that, Mavenir is there. Then you can see Dell is there also. Dell is also working for the private network. These are the Intel is also there. Okay, they are specialized in the private network. Okay, so these are the company. So I think Nokia is also leading right now. Cisco is leading right now. Cisco is the best actually. So the things I shown you, that is for the Cisco, and you can correlate and you can find the hardware in the system based upon the system actually. Cisco also you can do.
Okay, thank you.
Anybody else? What are the other questions? You have Oren. Yes, Carlo, I delivered the Oren session. Where is Carlo? It is mute. Okay, Carlo, I give you the access for the mic. Give me your feedback. How was the session?
Hello. Yes, the session was very good. Thanks a lot for all the information. I think we need to learn and study a lot for that.
Yes, in 1 hour we cannot finish all. See, last year I delivered lots of session, but this year first time I started again. Sorry, last year I didn't deliver session. Now I came back again. Now I will deliver more session. 5G private, ORAN, the physical layer, MAC layer, multiple. I have a plan to do lots of things this year actually for the webinar. Okay, so
okay, so for not just like a general question. So for private 5G, you can use it with license bands, and also you can use it with unlicensed, right?
Yes,
wow,
yes,
good.
yes.
And also following the question from our friend Kumar, is possible to make like a trial, like a small lab for testing or for showing like how to use the 5G and all of that?
I think in GitHub, there is a solution is there. You can find in the GitHub, you can find the solution. License band and unlicensed band, you ask me, it's totally depend upon the government regulation also. So yeah, because license band, you have to pay money. And if you have to pay the money for the private, so definitely it will be expensive. So mostly they go for the unlicensed band actually. Depend upon how rich you are.
No, I'm poor. We are poor here. Thanks a lot.
Thank you. Yes. Anybody else? Yes. Nokia has very good. You can say that private network solution. Nokia, Huawei, Nokia provide very good actually. Their solution is, I cannot share, but Nokia solution is very good. Anybody else? Any things? Any topic you need webinar, let me know, or we can conduct in future also. And also we can say that if you want to participate and if you wanted to do the webinar, please contact me. We can do together. There is no issue. Samir, let me open the mic for you. Wait. Yes, Samir. Samir, your mic is on now. How UE device dealing with the 5G? Is there already a good supply of 5G enabled devices?
Hello?
Yes.
You heard me?
Yeah, I can hear you. Please tell me.
Okay. My question regarding to the 5G private network. So if I we need to build for a small industrial 5G private network. So I can use unlicensed band, right?
Yes, you have to use unlicensed band. You cannot use licensed band.
Yes, this licensed band will be in the low or the high or the mid?
Mid 3.5 to that.
In which band? 3.5. 3.5. Okay. This is not related to the regularity actually, right?
No.
Okay. But what is the disadvantage when I work in the mid band?
No.
If the requirement for the industry maybe have a specific requirement to have, we need high throughput or low latency.
It's depend upon the configuration how we wanted to do actually. Okay, first if you wanted to create your own 5G private network, okay, so you need to you need to first find the solution what for what purpose you wanted to create the 5G private network. Okay, so when you wanted to create the private network, you can create the G-Node B by GitHub. You can create the 5G core network through GitHub. You can create your device. All three things you can create also. You need to find one cloud server, okay, and there is some solution I don't remember right now. Through that you can create your own private network. Yes, it's possible. You can create and you can do the testing also. In GitHub, solution is mentioned actually. If you go to the GitHub, you can find the solution.
Okay. Okay, get your point.
That issue you ask how the device you manufacture dealing with the 5G. See, when they create the device, there is two company. One is called MediaTek, one is called Qualcomm. MediaTek and Qualcomm is providing the chipset. When they are developing the new hardware, so they check what kind of demand is high actually. Okay, so you have to check the modem, you have to check the demand, and also country to country vary. US definitely they want more compatible software, incorporating software, so that they can connect multiple devices. They have to meet the standard, industry standard 4.0. They so many things they have to do. So right now, we just see the phones and we just see the IoT devices, not more. I think.
Okay.
Yes, Bhupendra.
Yeah. So I was just wondering, like this concept of CBRS FCC regulations. What is the similar concept in India? Like I was
India, I don't know. I think India, you have to check. Spectrum access system, or I think I will check in next webinar. We have the next webinar next month for NTN. Mr. Rahim Alizadeh will deliver. That time I will put these things.
Okay. Okay. Thank you.
Yes. Any doubt? You guys follow us on LinkedIn and find the YouTube channel. Hello.
Yeah, I already followed the two LinkedIn links and YouTube channel. Like,
yes,
it's really good content you provide. Thank you.
Mr. Alizadeh is also here. I think you you know about him. He's already shared lots of good content in detail. Actually, you can find him on the LinkedIn, and you can follow our page 5G 6G ORAN page. There also you can find this one. Okay. Okay, guys. So now there is no questions. So it's time to say goodbye. Okay. Take care. We will see you soon in the next webinar. So if you have any feedback, we can submit it. And if you want a certificate from my company, you can get it also. There is no issue. Those who want it, let me know. I will send to them because almost 50 people attended, so it's very difficult to prepare for them. Okay. Thank you so much. Take care. Bye-bye. Have a good day. I'll upload the video on YouTube. So